Okay, we'll go to our next speaker. Areg is the Triton lead and director of software engineering at Intel. The title of his presentation today is Triton Framework and Release Process. Everyone please welcome. Okay, we have a slight change on the title, no problem. Everyone please welcome Areg. Thank you.
Thank you. Okay, so a nice continuation of the talk from AMD. We are going to the Intel and what we do, how we enabled it, Intel backend for Triton, hardware we have and how we exploit the hardware features there. And this is the initial talk that we planned with Jason for the series of talk going deep into the compiler for the PyTorch ATX. So come to the next meetings and to learn more. And thank you, Red Hat, and thank you, Steve, for hosting this. Okay, so our public backend for Triton is out of the trunk or out of the mainline backend for Triton, officially supported by Intel. It's a fork, unfortunately, but it's being kept up to date, and we usually do pull downs like every 2 or 3 days. So it's very, very synced with the upstream Triton. It's being released, it's part of the official release for PyTorch. So if you go and do it, just install pip install PyTorch for Intel, you will get our backend, and you can use it on any existing Intel GPUs, but CPUs too. And most importantly, you can use on laptops that has Intel GPUs and Intel Battlemage B580, which is released recently. And out of the box, you can get some nice speed ups, which are always nice to get, especially for experimentation. So here is the GitHub address. We encourage everyone, and I'll talk to you on the next slides how to get it. So in architecting the Intel backend, we kind of followed usual steps and reused all the existing MLAR infrastructure that still is available in the Triton. So it reuses the Triton MLAR infrastructure with the Triton IR, then it goes to the Triton GPU IR, which is generic enough. Then it forks into target-specific IRs like NVIDIA GPU, or AMD has its own IR, and we engineered our own MLIR dialect here, which sits in the Triton repository called Triton Intel GPU IR, or GenIR. GenIR is a little bit later. Then we have a pass which creates LLVM, and that's where we reuse the GenIR. Then we engineer a pass that creates SPIR-V. And SPIR-V is the standard backend for all Intel GPUs for now. And then it goes to the driver and compiles to the binary. And it's completely up to date and has a very nice pass rate for all the unit tests for existing backends, and it includes Battlemage, and here we see Lunar Lake, the latest laptop. You just can install it through the PyTorch. So you do just pip install torch, and you will get it up and running, and you don't need any additional dependencies. Everything pip install will get for you, and this is very good for experimentation. Most importantly, it's available both on Linux and Windows. So if you have Windows, you can still use it. If you just want to install Triton without PyTorch, you can pip install from the PyPI, and it will work. But here you will need a bundle, or one API bundle, which is called Deep Learning Essentials Bundle. it will go and work. So Intel Triton is reusing, so we are on the path for bringing this portable productivity thing, which Jason talked. It's very important for us to bring this and enable all the Triton kernels that are running currently on other platforms to run on our platform. And we are using our graphics core, which is called Xe core or Xe2 core, to run this. It is the second generation, currently it's the second generation of Xe cores, which has 8 matrix multiply engine, supporting almost all popular types, data types, TF32, FP16, bfloat 16, and int8. And it has nice load prefetch store of the 2D blocks from memory, which is very nicely utilized in the Triton block-based programming model. Here is an example of how we can effectively utilize hardware using our data center GPU, which is available only through the cloud, unfortunately, but the utilization is pretty much the same on Battlemage and on data center max GPU. And here are some performance numbers relative to the handwritten kernels written in this library similar to Cutlass, or you can think it's over Cutlass. These are Matmos, and the first is the batch, and then the dimensions, MNK. Overall, we are getting 90+% of the performance for the handwritten kernels, which are pretty good. And there's still headroom for optimization. And we hope that we'll get better, and produce more stable compiler and more performant compiler, not only for Matmos, but for other workloads too. Currently, if you go to the Triton tutorials, all the tutorials are working and very performant out of the box. Also in our fork, there is a benchmark directory where there are lots of interesting benchmarks that you can compare on your card and play around with. Well, we also encourage you to do that. So it's still a challenge. We're not part of the upstream OpenAI. We are out of the mainline supported backend. It's not a bottleneck, it's not a showstopper, because we are part of the official PyTorch release process for Intel GPU. Still, we can do performance tuning is an endless work, right? It never ends. So more work, more workloads, more work. Proton enabling. Proton is the Triton profiler. It's progressing, and I think for the next version we will have the Proton enabled. And also with that will give us some fine granularity insights to the workloads. And yeah, the most important thing that all of the Triton kernels are functional and can run on any Intel GPU. So for that, I encourage everyone to use Intel Triton and Intel PyTorch, not Intel PyTorch for Intel, on your laptops and GPUs, and give us some feedback. And we need your kernels and more benchmarks. And encouraging everyone to come to the. I'm trying to fit into the 8 o'clock. Questions? Yes?
Why is it not part of the upstream OpenAI?
Why we are not part of the upstream of OpenAI? We were part of the upstream OpenAI, then we were removed from the upstream for the OpenAI maintenance reasons. We hope to get back to the upstream, but this is a question more to the OpenAI than to us. We are ready and we are keeping our fork synced and minimally distant from the upstream.
So what happened?
Sorry?
What happened?
OpenAI has a very specific focus on OpenAI ChatGPT, and maintaining and helping other backends is out of the scope for their main focus. And they are not running anything on Intel backend or Intel, so they considered everything else as a distraction, which is understandable. Any other questions? Okay, thanks.